And yeah, let's go. Great. Okay, so I think some of you met me in a course by Mr. Pearson, but my name is David Cato. You don't have to call me Mr. Cato. You can call me David. And I guess I'll start off just by welcoming you. I'm really glad that you decided to take this course. I'm really excited to begin teaching. And so I'll give you a little bit of background on myself. To start, if you've been here before, you might, some of it will be a review, but there's definitely some important information for everyone. And if we get through this quickly, I know this is often, can be dull, so I'll try to speed through it, the stuff that we can. And hopefully we'll get to some new material. Let's see, so a little bit of background on me. Kerbal or RockSim? I think so. I'll get to that later. So I am a chemical engineering graduate. I graduated from Virginia Tech a year ago. I've been doing some freelance work for the past year and just recently accepted a job last week in data science. So I have some material science background, but I decided to get into more programming and statistics, that sort of thing. I like that better. So I know Mr. Pearson had more of a strong computer science background if you had him last semester. So hopefully you'll get a new perspective from those returning, and anyone not returning, I guess I think it's just Kayla. Yeah, you'll just get to know me, I guess. All right. So let's get going with the slides. Okay, I guess be sure at any time just ask a question. Tell me if I'm going too fast or too slow. I'm still getting used to the whole pace of lecturing, especially I've never done an online lecture before, so just if I'm not going at a good pace, be sure and let me know. All right, so this class, do you want to be an engineer or something like it? There's a ton of jobs like it. Do you like to take things apart? Do you like building a game rather than playing it? You're curious about how to solder, use epoxy, repair a tent. Enjoy math, science, read science fiction, fantasy. Well, that's probably a lot of people fit that category, I guess. So you're among friends. Sorry if I'm flipping back and forth. I gotta catch myself sometimes. Let's see. Yeah, I like all of these things. So engineers, they learn by doing. You work with your head and your hands both. You create technology, not just consume it. So this class, I'll get to some questions. I see we've got some more here. I sound like a nervous kid who shakes at the board. I'm not that nervous, but maybe I shouldn't have had a cup of coffee about 3 hours ago. Let's see. Do I fly RC aircraft? I haven't recently, but I do enjoy it. Let's see. So class, 1 hour labs, meet twice a week online. Meet at your lab location every 2 weeks. Y'all don't ever meet, do you? I think this might have been a mistake. I don't have one. I just borrowed from friends. Let's see. No homework, no tests. Yeah, I'll check about the lab location. I'm pretty sure that's not you guys, though. Yeah, you're right. Okay. Let's see, digital portfolio. What will we be doing? Here's where gets interesting. All right, we're going to create, or if you already have created it, update a digital portfolio using things like HTML, Google Sites, and fall students, you can upload pictures of your work. So if we really get going quickly today, we'll might even be able to start doing some of this. Fall students. I don't know. Mr. Dubik gave me these slides to work with, and unfortunately I didn't have a chance to go through and edit them today, but I guess if you did some pictures in the fall, you can upload something. Yep. Here's where we get to some new stuff. Did you see this last semester? Ancient engineering, siege weapons, architecture. Can't remember. Okay, this is the new stuff. All right. So we're going to be doing some learning about ancient engineering, Roman siegecraft, onagers and trebuchets. We're going to learn about architecture, like what's in the Colosseum. Some technology. This is looks like Archimedes' screw. I don't know if you guys will get to use the 3D printer. This is definitely supposed to be for you, but okay. Albert Speer. I don't know who Albert Speer is. I don't think. Well, I'll let you know if you guys get to do some 3D printing. I'm not sure if you have access to the printers that the people in the lab do. Materials engineering. This is You're going to send your CAD designs. Oh, cool. So Jaden says that you guys get to send your CAD designs in, and Mr. Dubik will print them, and I guess he'll return them to you. So yeah, we'll do 3D printing using SketchUp, Tinkercad, and OpenSCAD or Inkscape, depending on what Mr. Dubik decides. All right, we'll get into some materials engineering, nanotechnology. Yeah, I'm sure you're right, Jaden. I didn't get the full update. Mr. Dubik and I still are working on getting on the same page, so let's see. And we'll go into environmental engineering, learning about solar power and doing some experiments with that. And yes, we'll get into aerospace as well using the Kerbal Space Program, which here is a lot better. Yeah. And then we'll get into some programming with Java and using the Unity game engine, which is a really cool, really easy way of creating a world, and really getting into the world quickly and dealing with. It's a really easy way to program a whole environment. Think games that you run around in the world and interact with the world, like a Zelda or something like that. All right, so let's practice. I know a lot of you people, you're familiar with it, so but can everyone raise their virtual hand? Gabe, I know you know how to raise your hand. Okay, I'm just going to move on since the rest of you guys got it. All right. Oops. Oh, here we go. Going back. Sorry about that. Okay. Problems with the... Here we go. What is going on? everyone registered for all of the webinars? I think, yeah, so all of the times available for your grade just in case you missed this one. I think Mr. Dubik does a virtual webinar just before this one, so if you know you won't be able to make this one, you should be able to make the earlier one. If you haven't, go ahead and do that now. I'm going to keep on going on, I guess. Have you registered on Edmodo? Has anyone, let me ask this. Let me know if you haven't registered for all the webinars or haven't registered on Edmodo, and I'll wait up. Otherwise, it automatically registers you, Gabe says. Okay, well, hopefully you've all registered then. Good question, Gabe. I'll ask about that. All right. Does anyone not have a Gmail account? All right. There's a Young Engineers of Today YouTube channel that you can subscribe to for the webinars. You'll recognize it by the green robotic head here. I don't see a link, so just Google for it. Young Engineers of Today YouTube channel. Yeah. Oh, and here's a form that just, let's see, where do I post this? All right, there's the link, and you should be able to, that's a quick questionnaire, pre-class questionnaire that we want all of you to fill. Oh, thanks, Gabe, for providing the link. Yeah, so that's I just sent you on chat the questionnaire that you need to fill out at the beginning, and then we'll give it to you at the end of the class. And you can talk about, the progress that you made and that sort of thing. But that really helps us measure how well we're doing. If we have a benchmark for the beginning and then measure, the difference in your responses at the end. So definitely fill that out. Yeah, I guess, go ahead and do that now. And raise your hand when you're done. Are you guys still going, or just not raising your hand? I don't know how long it takes. I actually haven't seen it. Okay, that's all right. it's all right, I'm just going to keep going because I think you just need to listen to me for the rest of this stuff. Engineering your future. Future is a big thing to think about. And I don't know how you guys feel, but I feel like, you know, I have been struggling with what I want to do with my life for, you know, before high school. I didn't know what I wanted to do. I saw a bunch of options for colleges, and I didn't really know the difference. You know, you kind of get an idea of what some colleges are like by visiting them and that sort of thing. But yeah, so you just you figure it out. So what does it take to be an engineer? It takes aptitudes in things like math, science, problem solving, perseverance, becoming a team player. That's a big one. Communication. Actually, we'll see later a list that shows how that's among the top. Being a team player and working well with people is one of the best skills you can have. Some of the best skills you can have. Let's see. Webster defines the practical application of science and math. Defines engineering as the practical application of science and math, as in the design and construction of machines, structures, vehicles, roads, and systems. Half the jobs created today are the result of technology. If you think about that for a moment, back in the day when people were all farming and you know, working, either hunting and farming, gathering, you know, those jobs, I mean, and the technology they had back then, you know, you could live your entire life and never see a new invention. You'd learn how to use tools that people had invented, but new inventions didn't come about very often at all. You know, it took years and hundreds of years for the first few inventions to roll around, and you know, ever since they started coming up faster and faster, you know, even in our grandparents' lifetime, the pace of inventions compared to what it is now is so much slower, and so and nowadays, so I mean, according to this, it doesn't say who it's from, but I believe it because I would think even more than half the jobs created today are the result of technology, since there's only 2% of the people in the U.S. that are even farming, and they're all using technology to farm. I don't know anyone that doesn't use some form of technology at their job. It doesn't have to know, so I don't know. It doesn't specify what technology is in this situation, but all right, we'll just keep going. However, many jobs are being lost to technology. It's showing here that, in fact, medium-skill jobs are easier and more cost-efficient for robots to replace, because low-skill jobs don't cost very much for people to pay. You don't have to pay people very much to do them. Low skill here is productive service, food prep, janitorial, cleaning, personal care services. And actually, I'll add to that that not only are the low skill jobs too cheap to replace with automation, but in fact, automation it just doesn't have the capabilities to replace a lot of the low skill jobs. And I say that, and I'll make that a little clearer. A lot of low-skill jobs are people working with their hands and with, you know, using their bodies in ways that it's very, very difficult to program a robot. How to, you know, robotic hands are barely even in their infancy stage. But medium-skill jobs where it defines here sales, office, admin, production, and operators. Their jobs are a little better defined for a computer. As far as sales and office workers and administrators and production workers, they a marketing job is an example. Whereas you used to market your things, you used to really have to know the market segment, and marketers still do. Don't get me wrong. All of these jobs, if you take them to a high enough level, all of these medium skill jobs become high skill jobs. But then they move out of that medium skill category. It's just the people who are in the medium skill jobs that will struggle, especially more in the future, as we used to need a lot more personal assistance, and now we have smartphones that, for the higher skilled jobs that replace the smartphone won't replace it, but for the lower skilled jobs, now we have smartphones to keep track of all of our day-to-day needs, and that's just one example of many where the medium skill jobs are actually affected more. Jaden asks, are we going to use the Kerbal demo or the full version? That's a good question. I'll ask Mr. Dubick. Full or demo? Okay. Let's keep going. So this is not our future. This is in the present time. You can see one guy. I don't know. Can you guys see my mouse? Yes, no. Okay. Well, oh, you can. Okay, Gabe. All right. So, can you see this little guy right here? I think there's another. I thought I saw another guy in here before, but the point is, the future is, machines, and it takes one high-skilled worker to fix the machines rather than a lot of low and medium-skilled workers to do what the machines are doing now. So where does that leave you? You guys will be going off to college if you choose to and have the money to pay for it, which, and if you can do that, then you've got a lot of options, but one day you will get out of college and you will have to get a job, unless you're loaded with money, and then I guess you can do what you like. But I'm assuming that you're like me and have to actually start working. Chemical engineers, petroleum engineers, take the big bucks. I was a chemical engineer. I didn't take a job in chemical engineering because it wasn't what I wanted to do. So I think some people might look at this and say, okay, I need to go into petroleum engineering because I'll get paid the most that way. But that's not a very good way of looking at things, because look at the scale here. If you major in physics, the average starting salary, which is the shorter one, the gray one here, the average starting salary is $50,000. And, once you start working and get into the average person who majors in physics ends up making $100,000 a year. So the point of this graph is not, if you want to make the most money or make a lot of money, go into petroleum or chemical engineering. The point of this graph is, pick something that you can do something with. That said, just because you don't, you should pick what your passion is. This is not me telling you, be an engineer, because it's not necessarily the best thing for you if you don't want it. So think about it. But if you want job security and is a priority, engineering is good. If your passion is engineering, engineering is good, because there will be jobs there, and a lot of them are really, really fun jobs. If you want to make the big bucks, then don't use this graph because this is the average person. If you want to make the big bucks, go into business, be a business major, start your own company, and get lucky. And then you start making big bucks. And that's because the reason why entrepreneurs aren't on here is because people who make a ton of money don't are not just smart but also lucky. They take a huge risk, and the average person doesn't. That risk for the average person, that risk doesn't pay off, and they don't make the top 10 college major list for that lead to high salaries. So I think I've belabored this point for far enough. So all right. So what's the difference between scientists and engineers? There's nothing wrong with either of them, but it's important to understand the difference. The scientific method relies on you make an observation, you make a hypothesis, you experiment based on, you test your hypothesis, you analyze the data that you collect, you draw a conclusion, and you end up accepting or rejecting your hypothesis. That is a perfectly fine way of doing things, and it's one of the ways that we really can draw conclusions from our world. Oh, and I missed the peer review step. So, of course, you have to, the peer review works. I am a robot, says Gabe. I guess I could be. Have you heard of the Turing test? If you can't tell that I'm a human, then maybe I am a robot. I don't know. That was a little reference thrown out there. My voice is going robotic. Okay. Is it the way I'm speaking, or is it the connection? Is it? Can you tell? A lag? Okay. Well, I'll try slowing down and speak slower so that maybe you have a better chance of catching what I'm saying. I'm sorry about that, Gabe. I can actually, let's see, I'll mute and unmute myself for, maybe that'll reset it. Has it been happening the whole time? It has? Okay. Well, maybe next time, as long as you can understand me, next time I'll try testing this out a little more and seeing if I can figure out what the problem is. Oh, okay. All right, let's keep going. Oh, I did that again. Okay, let's get back to where we were. Sorry about that. Okay, scientific method, peer review. Okay, so what do scientists do? They investigate, according to Einstein, they investigate that which already is, whereas engineers create that which has never been. So it's more of a philosophical difference, and figuring out what your calling is. Do you want to learn more about how the world is and drawing conclusions from the world? Scientists do amazing work. They investigate problems that can have very little impact or a huge impact, and there's really no way of knowing. So a lot of people, you might have to do your PhD. Your PhD might not mean anything. It might add very, very little to a field, but you keep pushing and you eventually make a huge amount of progress. Or your PhD you could be the next Albert Einstein or Alan Turing or any of these people and just be brilliant, but that's not most of us. So, whereas engineers, they try to, sometimes they use science, but they see how the world reacts and creates new things based off of that. Engineers do research, often involving pulling from science, math, pulling market data. Then they plan, they identify problems, brainstorm solutions. They select an idea, one probably, or a couple. They make models and simulations, and they make a proof of concept. They prototype it, they test it, they build it, test it, rinse, repeat, over and over. That's a whole cycle, and that's a lot of business is figuring out who your market is. That's marketing. Figuring, and a lot of business is the creation side comes from the engineers, but it really takes the engineering mindset, and that's an important thing that I didn't emphasize earlier when we were talking about jobs. Is it's really about your mindset to be an engineer. You can go into marketing, you can go into anything, you can go into sales, you can go into it doesn't matter. But having the engineering mindset of researching, planning, prototyping, and then producing, that's how engineers think, and how they build new cool toys and everything. So you all know there's a lot of types of engineering. Chemical, civil, I was chemical, mechanical, a ton. There's probably over 20 types of engineering that you can just major in. Yeah, here we go. Inside of mechanical is aerospace, automotive, biotech. Yeah, you get the picture. I clicked on that link earlier. I tried to open it and it didn't work, so we're going to skip that. So this is trying to make fun of a lot of things. What the user I don't know if you can read. Can you guys read that font that tiny? Anyone? No? Okay, I'll read it for you. What the user asked for is the first one. Then how the analyst saw it. I don't know why the analyst saw it like that. How the system was designed. 3 ropes. As the programmer wrote it. He didn't spend very much time. He took a shortcut, put up some sticks. What the user really wanted was a simple swing, and how it actually works is a stick and a string and another rope. Okay, so I don't know what this means. It's a commentary on analysts and systems and users, and really it's about communication. The important thing is, does it work? And only the user can tell you. I'm not going to read this. We've covered important things that employers look for. Communication, teamwork is on the top of the list. I mentioned that earlier. Strong work ethic, analytical and computer skills are maybe middle of the list. They can teach you that as long as you have the ability to pick it up quickly. And if you've already got it, that's great. And you can show them that you have these things. Then really you just need to work on communication, showing future employers your communication skills and teamwork skills. But yeah, we'll keep going. So your job, let's see, engineering your future. Well, I guess you should check this out. I'll give you a link in the chat. Give me a second. Okay, and if that doesn't work, then just Google Goldberger to go. Rube game, I guess. That Goldberger is a reference to the Rube Goldberg project, which uses a bunch of simple machines. I think there's 6 simple machines, and all other machines are based off of those 6. That's the idea. Mechanical principles and stuff. Okay. I think this is what the site looks like, and so it takes some engineering to figure out how to accomplish the goal. And I haven't done this, so I don't know the goal. It looks like maybe to get the ball in the door or something like that. I don't know. Gabe, you don't have to do it again if you've done it already. Here's another game, Tom's Trap-O-Matic. I'll let you Google that too rather than type it. It's another fun engineering game, I guess. Okay, is that it? Looks like it. Okay, so that's what this class is going to be about. We're gonna the rest of the future topics won't be so theoretical and what is an engineer. They'll be more here are some cool tools, and we'll teach you how to use them. Like we mentioned earlier, we're starting off with HTML, and we'll use Google Sites to put that up. And it looks like we are not going to have time to do anything today. I'm sorry I dragged it on, but Mr. Dubik wanted me to end this one about 15 minutes early. So in our last 3 minutes, next time and all of the future ones, unless we have a really good reason, but for all I know, all future webinars, they'll all be the whole hour. I'll start at 7 o'clock. If you're a couple minutes late, probably wait up. We'll try to start on time as much as possible, and we'll run to the end, to 8 o'clock in the future. So, yeah, I guess. Well, how was the pace of my speaking? How did that go this class? Goof? I guess you mean good. Good, I hope. Beautiful. Okay. Try to come more alive. All right. Like I was monotone. Are you being serious, Gabe, or are you pulling my leg? Serious. Okay. I'll work on it. Yeah, I didn't have a ton of preparation for this one, so I did look through the slides and everything, but I will be more on top of things next time, and hopefully I'll know where all the links will go, but I think I mentioned earlier I just got this today, so I didn't really have the time, but I'm sorry about that. And I guess I should mention too that this is something that you guys will hopefully learn some cool tools. You'll learn more about engineering, what engineers do, what being an engineer is like, and the different ways, different routes you can take to become an engineer, whether it's through rockets or aerospace, Unity game engine programming, 3D printing, casting and molding, materials engineering, all of that. You guys will learn that. What an Israeli accent? I don't think so, Gabe. This is the only accent I do, and you don't want to hear any of my accents. They're terrible. But this is what you should hopefully, you'll get an idea of some, even if you just, you like a couple of things and you want to take them further, you decide, oh, yeah, I really like that. Maybe I'll go into materials engineering or ceramics engineering or anything, really. That's one of the things that you can get out of this course. But one of the things that I'm getting out of doing this is I'm learning to become a better speaker and presenter. Like I told you, I just accepted a job, so I'm not doing this for the money. I might have done this for the money a while back, but just when I didn't have a job. But I'm still here, so I'm doing this because I really want to get better, and I want to help you guys. If you guys ever have any questions about colleges and that sort of thing, you can ask me anything, as long as it's appropriate. Let's see. So I guess what did I have for breakfast? This morning I had one of my favorite breakfasts, English muffin with eggs and salt and pepper, and a cup of coffee. All right. I'm already a little over what time Mr. Dubik said I should end this one, so if you guys don't have any more questions, I'll end the webinar and see you on Monday. All right, thanks for being here. I appreciate it, and I hope you got something out of that.